Hi, welcome you to this presentation on Analog Discovery Kit. Myself, Damodar, Product Manager from CoreEL Technologies India Private Limited. In this presentation of ours, we are going to be taking you through the implementation of a simple passive bandpass filter with the help of Analog Discovery Kit and Waveform Software. Analog Discovery Kit is a portable analog circuit design kit which comes with features like dual channel oscilloscope, function generator, 16 channel logic analyzer and dual power supply. And the uniqueness of Analog Discovery Kit is it is powered by USB itself. So it consumes extremely low power and it gives you a very portable platform to implement your circuits which you normally practice in your analog electronic circuits lab, logic design lab, analog communication and as well as digital communication lab courses. The Analog Discovery Kit is well complemented with an analog parts kit. As you can see over here, the analog parts kit gives you a wide range of analog parts which are normally used in our analog circuits and digital electronic design circuits concepts experimentation. As you can see over here, the parts which are offered in analog parts kit includes discrete resistors, capacitors and LEDs and even the integrated circuits such as buzzers and even operational amplifiers, and a wide range of components are offered in the analog parts kit, which gives you a comprehensive package to perform all your experiments which are prescribed in your analog electronic circuits and as well as digital electronics, analog and digital communication lab courses. In this presentation of ours, we are going to be taking you through the usage of analog discovery for the implementation of a simple analog circuit. Before getting started with that presentation, let us try to understand some of the key features of Analog Discovery Kit. Analog Discovery Kit, as you are seeing over here, it is a very portable, compact platform which gives you powerful range of features such as a dual channel oscilloscope, which you can see over here, +1 and +2 and -1 and -2 formulates the positive and negative terminals of the dual channel oscilloscope. And apart from that, you will get to see the 4 ground terminals which are offered in the Analog Discovery Kit, and plus it also gives you power supply which are indicated as V plus and V minus, and plus it gives you features like the Waveform Generator W1 and W2, and at the same time the Analog Discovery Kit gives you 16 digital IOs for managing all your digital circuits experimentation. So these signals which are coming out of Analog Discovery Kit can be made use with the help of the fly wires which are being indicated with different colors for the purpose of ease of utilization. The Analog Discovery Kit gets powered with the help of USB, as it has been shown over here. While connecting Analog Discovery Kit to your laptop or to your desktop machine, the setup should be done as it has been shown over here. Once if your setup is ready, you need to use the Waveform software for your experimentation. So in this demonstration, the passive bandpass filter has been constructed on a solderless breadboard, as it has been shown over here. The circuit which is been already constructed on the solderless breadboard is as shown over here. It constitutes of a 100 ohm resistor, 10 nanofarad capacitance and 1 millihenry inductor, and as I described earlier, the signals which are coming out of the Analog Discovery Kit, such as the waveform W1, which is basically a sinusoidal signal, is used for the experimentation, and +1 and +2 corresponds to the oscilloscope channels, channel 1 and channel 2 respectively, whereas the negative terminals of those channels minus 1 and minus 2 are connected to the common ground. So the common ground lead of the analog discovery kit, as it has been shown over here, right, it goes to the common ground of your circuit. So once if this circuit is been properly constructed on the solderless breadboard, which has been provided along with the analog parts kit, now we can get started off with our experimentation with the help of our waveform software. You can click upon the shortcut icon as it has been shown over here. When the Vigilant Waveform software diagnoses your analog discovery kit connection, it generates a message for you connected to discovery, and it also gives you the serial number of your analog discovery kit. Plus, it also gives you information such as the voltage at which the analog discovery kit is running, and the amount of current which it is drawing, and the temperature also. So this information you will get to see in the system monitor console in your Vigilant Waveform software. The Vigilant Waveform software comprises of two important ingredients, that is analog and as well as digital sections. In the analog section, you have features like oscilloscope, arbitrary waveform generator, and power supply. In the digital section, you have logic analyzer, digital pattern generator, static IOs, which can be used to feed any digital IOs which are needed for our digital circuits experimentation. Plus, the tool also gives you options like network analyzer, voltmeter, and spectrum analyzer. This wide range of features which are offered in waveform software makes analog discovery kit extremely powerful. So now let us get started off with our experimentation of passive bandpass filter design implementation with the help of analog discovery kit. In this experimentation, the passive bandpass filter has been designed for the specifications of lower cutoff frequency 15 kHz and upper cutoff frequency 150 kHz. So the circuit has been rigged up with the help of solderless breadboard. Now we'll try to feed the sinusoidal signal which is needed for our circuit with the help of the Waveform Generator software. As it has been shown over here. Once if you click upon your arbitrary waveform generator, you will get to see features like DC source, sinusoidal signal, and square wave, triangle, and even ramp up and ramp down signals. The waveform software, which offers you the waveform generator feature, gives you an option of generating even an aperiodic signals, which can be a combination of any of these signals which are being prescribed over here. At the same time, the periodic or aperiodic signal which you want to control with parameters such as frequency, amplitude, and offset can be controlled with the help of this graphical user interface with ease. For this experimentation purpose, I am going to be setting the frequency as 25 kHz and the input amplitude as 2.0 volts. And go back to your waveform software console and click upon the option oscilloscope. As soon as you open up oscilloscope, you tend to see that the waveforms which are being captured by oscilloscope in your earlier experimentation. Now for this part of our circuit analysis, we are feeding a 2 volts sinusoidal signal with a frequency of 25 kHz. I'll click upon the option Run Automatic Waveform Generator and then go to your oscilloscope, and in the oscilloscope click upon the option Run. So as you can see over here, the channel 1 which has been used over here captures your input signal, whereas channel 2 captures your output signal over here. The purpose of this experimentation is to draw the frequency response of a passive bandpass filter. Now let us go back to the Waveform software and set our input frequency as 10 kHz, and let us see the effect of that on our output. So as you can see over here, the response is outside our passband range, as a result of which the output voltage has gone down, as you can clearly notice over here. At the same time, the measurement window gives you the output voltage which is available in channel 1 and in channel 2, and at the same time it also displays out the frequency of your channel 1 and as well as channel 2. In order to draw the frequency response of any circuit, we need to vary the input frequency for a wide range of frequencies. Now we shall try to do the same thing over here. Let me change the input frequency to 25 kHz. Let us see the effect of that on our output. As you can see over here, since now the input frequency is within the pass band, the output voltage has increased. Now similarly, you can keep on incrementing your input frequency in incremental steps of either 2 kHz or 5 kHz or 10 kHz, and for each and every value of input frequency you can note down your output voltages and you can draw your frequency response plot. Conventionally, this is what we do in our electronic circuits lab, but in order to make our job more easier, in Waveform software we have a feature known as More Measurements. In More Measurements you get to see an option Network Analyzer. Network Analyzer gives you an option of drawing your entire frequency response plot, which is nothing but a Bode plot, with ease. So how to draw the frequency response Bode plot for this circuit? Go to your Bode plot, which is nothing but your Network Analyzer, and now click upon the option Run. As you can notice over here, the tool is capturing the frequency response of your circuit for a wide range of frequencies as per your input frequency variation. You can take a snapshot of this output which has been generated by the Network Analyzer, and you can save in a format of your choice. So similarly, the procedure which has been narrated over here can be used for your experimentation of concepts like single stage RC coupled amplifier, operational amplifiers, concepts such as unity gain operational amplifier circuit, and inverting amplifier and non-inverting amplifier using operational amplifiers, which we normally come across in our electronic circuits lab. And similarly, the analog discovery kit can be used for the experimentation of our concepts we come across in our digital electronics lab, such as multiplexer, demultiplexer, data encoder and decoder. Various other concepts can be implemented with ease. The uniqueness of analog discovery kit lies in its portability and at the same time ease of use. You can carry this kit wherever you want and you can get involved with your study and experimentation purposes with ease. Hope you enjoyed this demonstration of analog discovery kit. For any further information, log on to www.analog.com/university, or for further information and inquiries, write to us at upt@corel.com. Thank you.